When a query is slower than it should be, the plan tree tells you exactly why. In this module, we trace how to read, explain, analyze output, and find the one node where everything goes wrong. Every slow plan hides one of 4 problems: a row count lie that chose the wrong join, a buffer miss that forced disk I/O, a single node doing most of the work, or a nested loop that multiplied a cheap inner scan into an expensive one. The planner assembles a tree of operators. Each node carries 2 row counts, its estimate calculated before the query runs, and the actual count measured during execution. The gap between those 2 numbers is where your diagnosis starts. Here the planner guessed 50 rows would survive the status filter, but 48,000 actually did. That single misestimate cascaded upward, picked the wrong join strategy, and made the query orders of magnitude slower than necessary. The inner index scan looks almost free at 0.28 cost units per lookup. But that cost is per loop. With 10,000 outer rows, the inner node executes 10,000 times, multiplying that tiny cost into the dominant expense of the entire plan. Without analyze, PG_stats holds no information about the status column. The planner defaults to a generic selectivity guess, which is why its row estimate can be off by 2 orders of magnitude. Checking PG_stats before blaming the query is always step 1. The buffers option in Explain Analyze reports the same numbers. PG_statio tracks cumulatively. When an inner node shows a high shared read count, the working set does not fit in shared_buffers, and every loop iteration is touching the disk. The one line a reviewer must look for after any bulk load or large migration is a call to analyze. Without it, PG_stats is stale, the planner is guessing, and the wrong join strategy silently ships to production. 4 checks every time: row estimate versus actual, buffer hits versus reads, the single node where time explodes, and whether analyze ran after the data changed. Catch any one of these in review and you prevent a production incident.